And hello folks, welcome to this algebra review. So today I'm going to go through a lot of the algebra that we've covered on the course. Not quite everything. I'll talk about some of the things I'm not going to cover at the end of the video, but we're going to cover a lot of the content. If you could do everything in here, you would on a typical exam be scoring perhaps 15% more than someone who could do nothing here. So it's definitely stuff that's worth having. You'll find some of this you'll be completely fine with. You'll remember from what we've done previously. Some of it may have gone a bit rusty, and my aim is to try in a fast and light way to just get your skills up a little bit. I'm not going to try and explain things from the beginning. I'm going to assume that you've seen this before. A few exceptions I'll talk about as we go through the lesson, but we're going to assume that you've seen it before. This is a reminder of things you've seen previously. Right, let's make a start. Just before we do these questions, I'm going to point something out. On every page here, you will see I have put the relevant lesson here. That's linked on the 201 means 201 on the index page. There'll be a link on that. It's linked on the homepage, but I'll also put a link. Wherever you found this video, I'll put a link to the index page there. So if there's anything here you don't understand or I go a bit fast, go back and have a look at the lesson here and you'll get a bit more detail there. Right, let's make a start. So simplify x plus x plus x as opposed to simplify x times x times x. These are really, really often confused. So it's something I want to just be completely clear on, to make sure you're completely clear on. Right, if we're simplifying by adding, that's effectively 1x plus 1x plus 1x. Well, 1 plus 1 plus 1 is 3, so that's 3x. As opposed to, if we're simplifying by multiplying, x times x times x, that's where we use powers. So 3x is being multiplied is x to the power of 3. These, again, really often confused, so something I want you to be super careful about. Right, I'll give you a couple of questions, so I'd like you to pause the video and try those now. Okay, so we've got y plus y plus y plus y, that's 4y's being added, well that's just 4y. And down here we've got 5y's being multiplied together, that is y to the power of 5. Again, you probably find those okay because you've been able to look at a couple of examples here. Again, in the cold light of an exam hall, it's very easy to get those mixed up, so I want you to be super careful that you don't confuse the adding technique and the multiplying technique. A really common problem in maths generally. Right, now we've got a couple more, again, simplify questions. So 4x plus 2x, well 4 plus 2 is 6, so that's 6x. And here we've got 5x times 2y, so what we're going to do here is we're going to multiply the 5 by 2, which is 10, and we're going to multiply the x and the y, not much we can do there, just tack them together, so that will become 10xy. Okay, a couple of questions here. Slightly different to what we had over here, so maybe just need to think carefully before you answer those, but pause the video and try those now. Okay, so 7y take 2y, well 7 take 2 is 5, so that's 5y. 10y times 2y, well 10 times 2 is 20, and we're doing y times y, well that's going to be y squared. Again, very common that people forget to put the squared there because they treat this question as if it were this question here. So I want you to, again, really, really careful you don't get those two different techniques mixed up. Okay, a couple more simplified questions using powers. So if you remember the rule, if you're multiplying powers of the same thing, we add the powers together. That will be x to the power of 2 plus 3 is 5. And if we're dividing powers of the same thing, we subtract. So a to the 9 divided by a to the 5 is a to the power of 9 take 5 is 4. Okay, a couple of questions here. Again, a couple of little potential issues with these, so just give this a try. If you have any problem with them, don't worry, I'll go through them in a second. But yeah, pause the video and try those now. Okay, so for the first question here, little problem, there is no power here. I want you to remember, if you don't see a power, that is not power of 0, that's power of 1. So in this case, we're doing y to the power 3 times y to the power 1 is y to the power of, well, 3 plus 1 is 4. Really common to see people put 3 there, remember. You could even write it in. Examiners won't mind, they won't even notice if you put a 1 in here. If you don't see a power, power of 1. And for this question down here, if we see a fraction symbol like that, it's the same as divide. Division and fractions, division symbol, fraction symbol are basically the same thing written in a different way. So here we're going to do, as we did over here, we're going to subtract the powers. So b to the 8 divided by b squared is b to the power of 8 take 2 is 6. In an exam, you could get that, you could get that. You need to be comfortable with both of those. Okay, again, sticking with simplifying, this time we've got different kinds of things. So this is where I highly recommend circling stuff. So I'm going to circle the 5s and the 2s Note I'm circling the sign to its left as well, so not just the 2s but the plus 2s. 5s plus 2s is 7s. And then we've got 13t take 9t. Well, 13 take 9 is 4. That's positive 4. Why? Because 13 take 9 isn't minus. 13 take 9 is positive, so positive 4. And then don't forget the t. And down here, we've got 9x squared plus, sorry, pardon, 9x squared minus 6x squared. Well, I'm going to best just circle that. So 9 take 6 is 3, so 3x squared. And 3x take 5x, or 3 take 5 is minus 2, so minus 2x. There's nothing more we can do here. We can't simplify those because they're not the same kind of a thing. That's it. We're stuck with that. Right, again, 2 questions, so pause the video and try those now. Right, again, I'll circle. So circle the 8p, circle the minus 5p. So 8 take 5 is 3, so 3p. Minus 7 plus 2. If you're in any doubt about that at all, you grab a calculator. Minus 7 plus 2 is minus 5, so minus 5q. Again, common question, how do you know whether that's positive or negative? You just do the sum. 13 take 9 is positive 4, minus 7 plus 2 is negative 5. And under here, we've got y squared plus 3y squared. Now, again, little issue, there's no number in front here, so people often get a bit mixed up about what they're going to add here. If you don't see a number, it's an invisible 1 in front here. So that's 1 plus 3 is 4, so 4y squared. And minus 6 take 3 is not a case of 2 minuses making a plus. Minus 6 take 3, you're going down the number line as minus 9. Don't forget the y. Again, if you're in any doubt about that, you just grab a calculator. Minus 6 take 3 is minus 9. Okay, now back to simplifying by multiplying. So in this case, what we're going to do is we're going to first of all multiply the known numbers, the 2 and the 4. So 2 times 4 is 8. And then we're going to multiply, multiply the x cubed by the x squared. And to do that, we're not going to multiply, we're going to add. Remember, when you're multiplying powers of the same thing, you add the powers. So x to the power of 3 plus 2 is 5. And down here, we're going to divide. So 20 divided by 4 is 5. And x cubed divided by x squared, well, 5 take 2 is 3, so that's x to the power of 3. Okay, 2 to have a go at. So again, pause the video and try those now. Okay, so we're going to do 4 times 2 is 8, and then y to the 5 times y to the 5 times y squared is, we're going to do y to the power of, and we're multiplying powers of the same thing, so add the powers. 5 plus 2 is 7. And here we're going to first of all do 6 divided by 2. That's this 6 here divided by this 2 here. That's 3. And then we're doing y to the power of 6 divided by y squared. So that's where we subtract. So that's 6 take 2 is 4. Really easy to get those mixed up, I think, when you've got, particularly when you've got the same numbers here. If you put a 3 here, completely understandable, but kind of a little trap they can occasionally lay for you, so I want you to be really careful. You are dividing the 6 and the 2 in front here, but you are subtracting the 6 and the 2 here. Right, moving on. So we've got a couple of expand questions. So with expand, remember what we're doing is multiplying everything on the inside by whatever's on the outside. So in this case, I'm going to do 2 times x is 2x. I'm a big fan of these arrows. I think it really helps remind you that you're multiplying in each case. So 2 times x is 2x. 2 times 3 is positive 6. Or down here, we're doing x times x is x squared. And x times minus 2 is minus 2x. Really common, people forget to put this x in here and leave the answer as just minus 2 there. So that's why I like the arrow to remind yourself you're multiplying each thing on the inside by the number on the outside. Right, a couple of questions to have a go at. Just be careful with this negative here. And again, remember you're multiplying in each case. Little tip for you there. So I'd like to, again, pause the video and try those now. Okay, so I'm going to go 6 times x is 6x. Now, really common slip here is people often do 6 take 2 is 4. It's not that. We're doing 6 times negative 2. That's minus 12. And here we're doing y times y. That's y squared. And y times 3 is 3y. Again, don't forget the y here. Really, really common slip. Okay, now putting together this revision video, I've got a little bit of a problem. And the problem is that there are some lessons I put as optional online lessons. I didn't insist that people do every single topic. We didn't cover everything in class, certainly. Now, here's what I'm going to do. Here's what I would suggest that you do. Whenever I've got something which I gave as an optional online lesson originally, I've put that a little marker up in the top corner here saying it's optional. What I'm going to suggest is, if you've seen this before, great, just bear with me for 30 seconds and you'll be able to go through these questions. If, on the other hand, you didn't do them, just try them in this revision video. I'll try and keep the examples as straightforward as I can. Try them to see whether or not that's something you think you can have a go at. And if you think, yeah, actually that was all right, go and have a look at the lesson here. Now that you've got a few more months of algebra under your belt, even if at the time you decided not to worry about them, it might be worth going and having a look. And I think you can make that decision not as one blanket decision. You can make a decision for each topic. Just see, is that okay? Do I like it? I think I could do a bit more on that? Or do I don't like it? Don't want to do it? That's fine. Either way, it's entirely up to you on each topic. Right, let's have a look. So factorize is the opposite of expand. Factorize is to put back into brackets. Now it's called factorize because we're looking for common factors. So we're trying to see what we can divide these two terms both by. And I can spot that both of these numbers can be divided by 2. Okay, so 2 and then on the outside of a pair of brackets like this. And one good thing about factorize is the signs are almost always the same. So in this case, I'm just going to put a plus sign here. Then I'm going to ask the question, what would I need to multiply 2 by to get 6x? Well, to get the 6, I'd need to multiply 2 by 3, and I'll need an x in here as well. So 2 times 3x would be 6x, so we know that if we expanded this, we'd get back to 6x here. And what would I need to multiply 2 by to get 8? Well, I'd need to multiply 2 by 4. And that's it. That's what factorizing is, putting into brackets. Right, another example under here. So what can I divide 12 and 20 both by? I could divide them both by 2. I actually can see a bigger number though, and one thing that you need to bear in mind with factorize is you always need to look for the biggest number you can. I can see that these two numbers can both be divided by 4. 4 is what we call, if you remember, the highest common factor of these numbers. Pair of brackets. What would you need to multiply 4 by to get 12? Well, that would be 3. So this will be 3x. And what would you need to multiply 4 by to get 20? That would be 5. This will be 5y. And that could be a couple of marks, so it might be worth having. Right, I'm going to give you a couple to have a go at, so I'd like you again, pause the video and try those now. Oops. Okay, so let's see what we've got here. What can I divide 6 and 9 by? Well, I can divide them both by 3. So 3 goes on the outside, plus sign here. To multiply 3 to make 6, you need to multiply it by 2. That'll be 2y. And to get multiply 3 by something to get 9, you need to multiply by 3. So 3 times 2y is 6y, 3 times 3 is 9. Now here, there are a number of things you could divide 15 and 30 both by. What you're looking for is the biggest number. So the biggest number is 15. If you use 3 or 5, you would get marks for that, but the biggest number, to get you all the marks, you need to divide them both by 15. Right, what would you need to multiply 15 by to get 15a? Well, that would just be a. 15 times a is 15a. And what would you need to multiply 15 by? Well, to get 30, you need to multiply by 2, so that will be 2b. This one getting a little bit more awkward. It's doable, but what I think I would say about factorize, in fact, I do say it in the lesson on factorize, is that the questions vary in difficulty enormously. They start off fairly pleasant, this kind of thing here. They definitely become quite tough. But again, if you've got a bit of time and you're feeling fairly confident with the algebra that you've done so far, it might be worth a look. Now this was another optional online lesson. This bit definitely everyone can learn. So even if you didn't do this first time round, I'm going to explain this now, and this one is absolutely fine. These can get more awkward, as you'll see if you look at the lesson, but this particular question and the question over here is going to be fine. Right, what do? If you're raising a power to a power, like x squared, which itself is being raised to the power of 4, all we do is we multiply the powers together. So that's 2 times 4 is 8. That's it. That's a mark. Let's see, a mark that's worth having. Right, try that one there. Okay, so all I'm going to do is I'm going to do y to the power of 3 times 5 is 15. Done. Now again, these can ramp up in difficulty. If you have a look at the lesson, you might find you do the first 10 minutes or first 5 minutes even, you think after that, I think I'll stop as it gets a bit more difficult. But I think at this stage, if you didn't look at it first time round, it's probably worth it for a few minutes. Certainly, I just want you to remember that. If you're raising a power to a power, you multiply the powers together. It's definitely something I want you to all know. Okay, so a topic that I want everyone to be absolutely comfortable with is solving equations. This is the idea, if you remember, of the balancing scales. Whatever we do to one side, we need to do the same to the other side. So in this case, I've got to get rid of two things. I've got a +1 that I don't want, and I've got a little invisible times 2 here. So first of all, I'm going to get rid of the +1 by doing the opposite of +1, which is to take 1. If I take 1 from the left, I have to take 1 from the right. Equal sign goes directly underneath like that. 10 take 1 is 9. 1 take 1 is 0, so all I'm left with here is just the 2x. Then I've got a times 2 I don't want. Opposite of times 2 is divide by 2. If we divide the left by 2, we've got to divide the right by 2. Equal sign underneath. So 9 divided by 2 is 4.5. And 2 divided by 2 is 1x, or just x. Now I think that's right. One thing I'd always recommend when you're solving equations is when you get the answer, put it back in and see, does it work? Put the answer back in here. So in this case, let's grab a calculator for this when I can. There it is. Oops, what's happening here? There we go. Right. So 2 times 4.5. Remember that invisible times sign there. So 2 times 4.5 plus 1 is indeed 10, which means I'm absolutely confident that's the right answer. So always a good idea when you're solving an equation, put the answer back in, see if it works. Right, once I've got yourself, so I would like you to pause the video and try that now. Okay, so what I'm going to do first of all is I'm going to get rid of the -2 by doing the opposite of -2 is to add 2. Remember, you're always doing opposite to get rid of things. So I'm going to add 2 to this side here. 25 plus 2 is 27. -2 plus 2 is 0, so I'm left with just 3x here. And then I've got a times 3 I don't want. Opposite of times 3 is divide by 3, so I'll divide this side by 3. So 3 divided by 3 is 1x, or just x, and 27 divided by 3 is 9. Quick check, grab my calculator, which is causing me problems today. Where are we? Let's have a look. So I think x is 9, so 3 times 9 minus 2 is indeed 25, so I know that's the right answer there. Now, just to stress, as we said in class, if you do that a different way, as long as you've got the answer here, 4.5 here or 9 here, you will get the marks. That's absolutely fine. I'm a big fan, though, of the balancing scales idea, because as the questions get more difficult, which they will, I think the balancing scales method is a method that's, I call it, extendable. It allows you to do something and then cope with more complex questions after that. So if you don't like that, but you think, oh, I can do it, great. But if you find that as the questions get more difficult, you're not able to cope with those, you might need to think about using something like what I've just done there. Right, so let's push on. Where are we? Okay, so another solve equation question, just with a pair of brackets in. So what we're going to do here, well, let's expand the brackets. So I'm going to go 3 times x is 3x, again using those arrows to remind myself to multiply, and 3 times positive 4 is positive 12, equal sign directly underneath, 27. Going to get rid of the plus 12 by taking 12. So we'll take 12 from the other side, equal sign directly underneath. 27 takes 12 is 15. That leaves me with 3x. And I've got a times 3 I don't want. Opposite times 3 is divide by 3. So I'll divide this side by 3. So that'll be x, and 15 divided by 3 is 5. Again, we can grab a calculator and put that straight in. So all I'm going to do, again, is just rewrite this side here, replacing the x with 5. So 3 brackets 5 plus 4 close brackets equals 27. Great. So we know we're right. Right, again, once I've got yourself, so pause the video and try that now. Okay, here we go. So I'm going to do 4 times x is 4x, and 4 times minus 1 is minus 4. Again, not 4 take 1, 4 times minus 1 equals 28. I'm going to get rid of the minus 4 by doing the opposite, which is to add 4. So I'll add 4 to this side here. So 28 plus 4 is 32, and that'll be 4x here. And I've got a times 4, so the opposite is divide by 4. So I'll divide this side by 4. 32 divided by 4 is 8. Again, I think it's 8, so let's just check. 4 brackets 8, take 1, close brackets, is indeed 28. We had on the right, so we know that's the right answer there. Right, this kind of question here is where things I think get more difficult and where the balancing scales method I think is really handy. So in this case we've got x's on both sides of the equation. And the way we handle that is when you've got x's on both sides is you get rid of the smaller quantity of x first. So in this case I can see I've got 5x here and 3x here. I'm going to subtract 3x from both sides. Okay, so 5x take 3x is 2x. That'll be 2x plus 3. 3x take 3x is 0, so all I'm left with here is 11. If that had been a minus, I'd have to write minus. Because it's a plus, if we see an 11, we'd assume it was positive anyway, so we can just write 11. If you wrote plus, it wouldn't be a problem. Okay, I've got a plus 3 I don't want, so let's take 3 from both sides. Equals underneath. 11 take 3 is 8. That'll be 2x. And I've got a times 2 I don't want, so opposite is divide by 2. That'll be x equals 4. Okay, so I think x is 4. Let's check it. So what we're saying here is that 5 times 4 plus 3 should be the same as 3 times 4 plus 11. Right, again, let's grab a calculator. You can probably do these in your head anyway, or some of these, but I just think it's faster probably just to, and you can always use a calculator to check things. So 5 times 4 plus 3 comes to 23. So I think that's 23. I'll say big one. If I put the 4 back in here, I get 23 on this side. If I put it onto this side, that's 3 times 4 plus 11, and I'm hoping this says 23, which it does, which means I've got the same total both sides. As long as that's the same number, we know that's the right answer. Right, want to have a go at yourself. So again, pause the video and try that now. Okay, this one's a little bit more awkward, I think, because of the negatives. So if you had any problems with this, don't worry. Let's go through it carefully together, though. So first of all, I've got 7x and 2x. So the smaller quantity is 2x. So let's take 2x from both sides. Equals underneath. So 7 take 2 is 5. So that's 5x plus 2. 2x take 2x is 0. So I'm just left here with minus 8. Because that's a minus, you have to write that minus in here in a way we didn't have to here. Because if you don't see a sign, we'd assume it's positive. Here, we need to have that negative. Okay, if you've done that, if you've got that, you've got yourself a mark for that question. This will be a 3-mark question. That's 1 already. Now next, this is the bit that maybe gets a bit more awkward, and something I ought to say before I go any further with this question. As I think I say in the lesson here, the online version of this lesson, these can vary in difficulty. So sometimes you're doing a whole bunch of questions and they're fine, doing great, and all of a sudden you get a really horrible one, and it's often to do with negatives, which cause the issues. So it's the kind of thing where don't worry if you get the odd one wrong. Everyone does from time to time. That's absolutely fine. If this causes you any problems, that's okay. But what it suggests is maybe it's worth going and having a little bit more of a look at that lesson. Right, anyway, let's keep going. So I've got a plus 2 here I don't want. The minus 8's fine. That's sitting over on this side here. It's not causing any issues. The problem is I want to get x on its own as a plus 2. So what I'm going to do is take 2 from both sides. Equals underneath. Right, so that will leave me with just 5x on this side, and minus 8 take 2. If you're 8 out again, you can grab a calculator. Minus 8 take 2 is minus 10. And then I've got a times 5 I don't want. The opposite is divide by 5. So minus 10 divided by 5 is minus 2. Right, again, let's check it. So 7 times minus 2, right, plus 2. Comes to minus 12. So when I put the x in here, I got that total be minus 12. Let's do the same over here. So this is 2 times minus 2 minus 8 That comes also to minus 12, so I've got the same total on both sides, which means I know I've got the right answer. But again, to stress, if you got that one wrong or you got stuck, don't worry. This question here is definitely a step up from this question here. But with practice and time, you'll get better and better at these, and that's just something that it needs a bit of work occasionally from just to go through. Right, let's move on. Okay, now we're going to look at some inequality questions. The thing I want to stress about these, which I said in class, is when you're solving an inequality like this, you treat this as if it was an equal sign whilst not writing an equal sign. So we're going to do exactly what we just did on the previous few questions. I'm going to first of all get rid of the minus 2 by doing the opposite, is to add 2. If I add 2 to the left, I'm going to also have to add 2 to the right. I'm going to keep the same symbol pointing the same way, like that. 13 plus 2 is 15. Minus 2 plus 2 is 0, so that's just 3x. And then I've got a times 3. Well, the opposite of times 3 is to divide by 3. So I'll divide this side also by 3. So that'll be x, and that'll be 5. And that's it. That's the right answer. Whatever you do at this stage, because I know people do this very often, is don't go and write x equals 5. That's wrong. That's turned a right answer 2 out of 2 into a 1 out of 2, because this is not correct. You keep the same symbol the same way all the way through. Right, that's it. So I'm going to give you one to have a go at. So I'd like you to pause the video and try that now. Okay, so I've got a plus 1 I don't want. Let's take 1. So if we take 1 from the left, we've got to take 1 from the right. 13 take 1 is 12. 1 take 1 is 0, so that's 4x. I've got a times 4 I don't want. Opposite times 4 is divide by 4. So let's divide this side by 4. So x, and 12 divided by 4 is 3. And again, don't write x equals 3, just leave it like that and you'll get all the marks. Also notice that I've gone through the whole thing there without even saying what these symbols are. This actually says 3x minus 2 is greater than 13. This says 4x plus 1 is less than or equal to 13. Even if you didn't know what those symbols were, you can still get all the marks for these questions by just keeping the same symbol pointing the same way all the way through. So don't worry too much if you get a little bit lost about which one's which. For these questions, you can get marks even if you didn't know that. Okay, where you do need to understand these symbols is where you're asked to represent inequalities on a number line. So this, if I read this out now, says x is less than 4. Now to do that, what we're going to do is we're going to put a circle over the 4, like that. I'm going to have a line that goes right down to the end of the line down here. It doesn't quite matter how far, just try and get somewhere towards the end or off the end of that line like that. And that's that. I also notice that the arrow is pointing the same way as the inequality sign. That will always be the case. So if the arrow is pointing to, if the inequality sign is pointing to the left, the arrow will be pointing to the left. If you get one of these ones with two sides, then all we do is we put a circle over each number, circle over the minus 1, I'm going to put a circle over the 3, I'm going to have a line connecting those like that. And really important, where you see the equal sign underneath, that's the less than or equal to, or the less than or equal to here, we colour in those dots like that. That's the way we can show on a picture that the minus 1 is allowed or the 3 is allowed. That's x is all numbers between minus 1 and 3. Right, want to have a go at yourself, or 2 I should say, so got you 2, pause the video and try those now. Okay, so first of all, I'm going to put a circle over the 2. I'm going to put a line going to the same direction as the inequality symbol, so up the number line like that. And because there's an equal sign underneath, I'm going to colour this in like this. And for this question here, I'm going to put a circle over the minus 5. I'm going to put a circle over the 3. I'm going to have a line connecting them like that. And because we have an equal sign here, we're going to colour in this dot. And because there's no equal sign here, we're not going to colour in this dot. Now, flipping it round, what we've got here now is we've got a graphical inequality on a number line, and we're asked to write down what that is. So first of all, I'm going to put my x here. And my inequality sign, again, is going to point the same way. So it's going to be pointing up the number line like that. And I'm going to put minus 1. Because the circle's over minus 1, and because that's a coloured in circle, I'm going to put an extra line under here to indicate it's greater than or equal to. Now when you've got to represent, you've got to write down inequality when you've got the two dots like this, we put an x in the middle, always have your arrows pointing downwards. Just a general thing to remember. Arrows, if you've got two of them, arrows always pointing to the left. And then just put my numbers. So in this case 1, and in this case 7. And because these dots are not colored in, I'm not going to put the equal signs underneath. Right, to have a go at yourself. So pause the video and try those now. Okay, so I'm going to put my x here. I'm going to have my inequality sign pointing down, again the same direction as the arrow here, and 2. I've actually got my face in the way here, so I'm going to have to put my answer over here. So I'm going to put x in the middle, 2 arrows pointing downwards like that. The first dot's over -2, the second dot is over 4, and because this is not coloured in, I'm going to leave that, but because this is coloured in, I'm going to put a line like that, and I'm done. Okay, back to another optional lesson. This one, again, I think this is worth knowing. I think it's just a thing that pops up in the exam from time to time, so it's worth having a look at. If you wanted to do more on this, if you go to lesson 208, which is actually something we've all done, there's a little thing, I think it's in the helpful stuff column, and it's called bonus lesson, little fractions in big fractions. Have a look at that. This will give you a little start point. Maybe have a look at that, but it's not long. It's definitely worth a look, because it will add, particularly if you're quite good at equations and you quite like them, it'll just give you another little string to your bow just in case this pops up. Right, so what we need to do here is whenever you have a big fraction, when the entire other side has got the fraction sign like that, is we need to get rid of this first. You always get rid of big fractions before anything else. And again, we get rid of stuff by doing opposites. So I've got a big divide by 4. So the opposite of divide by 4 is to multiply by 4. If I multiply the left by 4, I also multiply the right by 4. Equal sign underneath. 5 times 4 is 20. And the bit that always causes confusion is when I first introduced this, I have done this in class from time to time, but it generally doesn't go down too well. People often have a few issues with this. Is when you multiply by 4 here, all we're doing is getting rid, I should say, of the divide by 4. So all I'm going to have here is 2x minus 6. People always want to multiply the 2 by 4 and the 6 by 4. Not that. The act of doing this just gets rid of this. Right, after that, it's exactly what we've seen before. So I'm going to first of all get rid of the -6 by adding 6. So let's add 6 to this side, equals underneath. 20 plus 6 is 26. -6 plus 6 is 0, so that'll be 2x. And I've got a times 2 I don't want. Opposite of times 2 is divide by 2. So let's divide the other side by 2. 26 divided by 2 is 13. And 2 divided by 2 is 1, so 1x or just x. Let's grab a calculator when it's deciding to behave itself. Right, so fraction button first. So that's 2 times 13. Again, remember that little invisible times sign there. So 2 times 13 minus 6. Go to the bottom and press 4. And I'm hoping when I press equals, it's going to say 5, which it does, which means I know that's the right answer. Right, want to try yourself. So when you're ready, pause the video and have a go at that. Okay, so I've got a big divide by 2. So to get rid of that, we're going to multiply the left by 2. So we've got to multiply the right by 2. Equals underneath. That'll be 26 on the right. And again, the whole point of multiplying by 2 is not to have the divide by 2. So I'm left with 3x minus 1. To get rid of the minus 1, I'm going to add 1. So let's add 1 to the other side as well. 26 plus 1 is 27. Minus 1 plus 1 is 0, so that's just 3x. And to get rid of the times 3, opposite is divide by 3. So I'll divide this side by 3. So 3 divided by 3 is 1x, or just x. 27 divided by 3 is 9. Again, I think that's right. Let's check it. This is really having problems today. Right, so fraction button first. 3 times 9 minus 1 over, and that'll be 2. Press equals, I get 13, so I know that's the right answer. Right, to be honest, these don't get harder in the sense that that's just a thing you need to know. That's how you handle these. Maybe the odd little thing here and there, but so probably worth having a little look for a few minutes at that lesson, but only if you're feeling generally confident with the other kind of equations we've seen. So I'll leave that up to you again. Right, so here we've got an expand and simplify question. So two things to do. First, we need to expand both these brackets. Then we need to simplify by grouping things together. Let's do the expand first. So we're going to do 3 times x is 3x. Again, using my arrows, it really helps to remind me that I'm multiplying in each case. 3 times 4 is 12, so positive 12. 5 times x is 5x. Note that's a positive 5 times positive x, so I need to put a plus sign in here. I need to put that, otherwise I'd have two separate terms with nothing linking them. So I need to put this plus sign here. And 5 times minus 4, not 5 take 4, 5 times minus 4 is minus 20. Okay, I've done that. Now I'm going to simplify. So I'm going to group things together. Well, I can group together the 3x with the 5x. 3x plus 5x is 8x. I've got 12 take 20. Well, 12 take 20 is minus 8. So that leaves me with minus 8 there. And that's it. Expand gets us probably a mark. Simplify gets us another mark. Right, want to try yourself, just be a little careful with this minus, just watch out for that. That's again, I've made this a little bit harder perhaps than the question on the left here, so be careful with that negative there, and yeah, give it a try. So pause the video and do that now. Okay, so I'm going to go 7 times x is 7x, 7 times minus 1 is minus 7. Minus 4 times x is minus 4x, and minus 4 times 3, not minus 4 plus 3, minus 4 times 3 is negative 12. Okay, that's the expand part done. Now I'm going to simplify by grouping, so I can group the 7x and the minus 4x. So that's 7x take 4x is 3x. And minus 7 take 12 is, starting at minus 7 going down the number line, is minus 19. Again, just to stress, if in doubt, where are we? Minus 7 take 12, there we go, minus 19. If you're in any doubt at all, use a calculator. Now, there is a different kind of expand and simplify question. Again, I put this as an optional on the lesson. I didn't cover this in class. At least I don't normally cover this in class. So what we've got here, it's got two pairs of brackets physically next to each other with nothing in between like that. We call these double brackets. Again, there's a whole lesson on here you can go and have a look at if you think this is all right. Now, a few ways you can do this. The way I'm going to do it is, I tend to find people get this right more often if they do this, is I'm going to do what I call the grid method here. So if you've seen this before, great. If you haven't, don't worry. I'll try this here. You can see how you get on with it. If you like it, fantastic. If you don't, just don't worry too much about this topic. Right, so I'm going to put my x here and my 2 here, my x here and my minus 4 here like that. It would not matter, by the way, if I'd put x minus 4, x2. Makes no difference whatsoever. So we're going to break this down and do 4 little multiplications. Starting off with x times x is x squared. X times 2 is 2x. X times minus 4 is minus 4x, and 2 times minus 4 is minus 8. And next, I'm just going to write these out. So x squared plus 2x, no, that's a positive here, plus 2x minus 4x minus 8. That's the expand part done. Now the simplify, all we're going to do is group things together. So what have I got here? Well, I've got x squared, but there's no other x squares. There's nothing else that's the same, so nothing I can do there. X squared. 2x minus 4x, these are the same kind of thing. In fact, I might just circle these here to show you that. Circle that and circle that. So 2x take 4x is minus 2x. And there's no ordinary numbers, so that'll be minus 8 here like that. Right, so just give this one a go and just see how you get on with it. So I'd like to pause the video and try that now. Right, again, I'm going to draw my lines. So like noughts and crosses lines, except with an extra line in each case. So 3 lines going down like this, and 3 lines going across. Sorry, these are a bit squiffy. There are we. I'll get rid of a bit of extra stuff here. Right. Okay, so I'm going to have my x and my minus 3, and my x and my 5. So x times x is x squared. X times minus 3 is minus 3x. X times 5 is 5x, and minus 3 times 5 is minus 15. I'm just going to write these out here, so that'll be x squared minus 3x plus 5x minus 15. Again, I've got no other x squares apart from the first one, so x squared goes here. Minus 3 plus 5 is positive 2. Again, you can always grab a calculator if you're unsure about that. Minus 3x, let me just circle them again. Minus 3x plus 5x, again, is positive 2x, and minus 15 is just minus 15. And the good thing about these is that once you've got your head around them, pretty much every question looks exactly the same as the one that came before. So although we didn't do it in class first time round, if you thought, well, that's okay, there's a few extra little bits that might make things awkward. When you get two negatives, like one negative here, one negative here, that can make things a bit more awkward. But I would say if you felt that was kind of all right, go and have a look at the lesson and see how you get on with that if you haven't already. Right, okay. What we've got now is we've got a formula here, a equals bc plus d, and what we're asked to do here is to substitute, to replace these values of these unknowns with known numbers. This is called substitution. We're substituting, replacing each of the letters with what we're given down here, with the aim of finding the one thing we don't know. So I don't know a, but I do know b is 3, I know c is 5, and d is minus 4. So all I'm going to do is write a equals, now bc, remember, means b times c, so that's 3 times 5, not 35, 3 next to 5, 3 times 5, plus, and d is minus 4, and now I'm going to put that into my calculator. So let's type it in. So I'm going to go 3 times 5 plus minus, there we go, minus 4 equals 11, a equals 11. Done, that's it. Right, give this one a try. So I'd like you to pause the video and try that now. Okay, so I've got E equals, right, so I know F is 10, minus, now G is minus 3. Watch that double negative. If you made a mistake here, it's probably because you didn't see the two negatives. So that minus there is this minus here. G is minus 3, so minus 3, again, invisible times here, so times 6. So you've got to be really careful with negatives that you don't accidentally miss one, particularly when there's 2 in the question. Right, let's grab a calculator for that. So that's 10, take minus 3 times 6, grab my calculator, press equals there, and that tells me that's 28. Now this next question is very similar, it's the same topic, but it's a bit more awkward because what we've got here is, if you look carefully, we're asked to find y. We know what x is, we know what z is, we know what f is, we don't know y. The point I'm trying to make here is y is not the thing on its own, which makes it definitely a bit more awkward. Right, let's start off though by doing the substitution. So x is 30, so 30 equals y times z is 4, y times 4 minus f is 2. Now a couple of things I can do here straight away. One is y times 4 is 4y. So I'm going to just write it like that, take that times sign out, because I think it's just easier to handle that if we've put it as written as 4y, minus 2, and that's 30. And the other thing is, which is a common technique that you might use from time to time in solving equations, and by the way, this is an equation to solve, we're trying to find out x is, this is the balancing scales idea. But a common technique is, if the thing you're trying to find is on the right, you probably, most people are more comfortable with the thing they're trying to find being on the left. What you can do at this point is just swap it around. So 4y minus 2 equals 30. Just pick up the whole of the right, stick it on the left, pick up the whole of the left, stick it on the right. That's perfectly fine. Then we've got again the balancing scales idea. Whatever you do to one side, do the same to the other side. So in this case, I'm going to get rid of the minus 2 by adding 2. Means I've got to add 2 to this side here, equals underneath. 30 plus 2 is 32, and minus 2 plus 2 is 0, so that's 4y. And I've got a times 4, opposite is divide by 4. So that'll be y equals 8. And we could even check it. We think y is 8, so that's telling us 8, again, times 4 minus 2. Well, 8 times 4 is 32, take 2 is 30, which is what we had for x. So if we put the values in the right, we get the same as we had on the left, which means I know that's the right answer. So again, we can see the value of being able to solve equations, because it doesn't just help that topic. Solving equations leaches into all different areas of algebra and other things too. Right, want to try yourself. So yeah, I'd just like you to, oh yes, before you do pause, I was going to say, this I've just slightly changed things around here. It's a little bit different. I think in some ways this is an easier question than the one you've got over here, but just bear in mind you can't quite copy down. Substitute each of these values in here and then do whatever you need to do to solve the equation. So pause the video and do that now. Okay, so 8 is 80, so 80 equals 5. This time we've got a unknown number here, so 5b is, we don't know, but that's the point, isn't it? We're trying to find b, so 5b plus 15. So I don't need to do any kind of, like here where I had to switch them around. I've already got this in the right form, but I don't like, again, b being on the right, so I'm going to switch it around. 5b plus 15 equals 80. Pick up the right, stick on the left, pick up the left, stick on the right. Then again, balancing scales, so let's take 15 from both sides. That's 65. 15 take 15 is 0, so that's 5b. Got times 5 I don't want, opposite is divide by 5. 65 divided by 5 is 13, and 5 divided by 5 is 1b, or just b. Again, I think that's right, so let's just check it. If that's correct, then 5 times 13 plus 15, again, just replacing b with what it is, which we think is 13. Okay, let's grab a calculator for this. Right. So 5 times 13 plus 15 comes to 80, which is great because that's what we were told A was, which means, again, I know that's the right answer there. Now, another optional lesson. This one here is something that I think examiners tend to think is fairly easy. I think it's something that you sometimes see even in the first half of a paper. It pops up in the first 50s from time to time. But actually, I think students tend to find this quite difficult. So if you decide you don't want to bother with this, that's fine. Again, if you've done it already online, great. If not, then maybe have a try this one. If you don't like it, I honestly, even if it comes up in the first half of the paper, if you sack it off, it's a couple of marks that most people doing the exam will not get. Right, what are we trying to do here? To make x the subject is to get x on its own. At the moment, y is the subject, y is on its own. I want to get x on its own. And again, the balancing scales idea. So let's see what we're going to do first of all. Well, first of all, I want to get x on its own. X is currently on the right. Again, we said before, it's generally easier if you put it on the left. So I'm going to just switch this around like this. Ax plus b equals y. All I've done again is pick up the right, stick it on the left, pick up the left, stick it on the right. Now, what we're going to do now is we're going to do the same thing to both sides in order to get x on its own. So to do that, or to get x on its own, first of all, I'm going to get rid of this plus b. And to get rid of plus b, we do the opposite of plus b. Well, that's take b. So if we take b from the left, we've got to take b from the right. So if we take b from the left, it leaves me with just ax here. This is the bit that always causes problems. So y take b is literally just y take b. You can't take b from y because you don't know what those numbers are. You can't take them away from each other. All I can do is write that. Then what I'm going to do next is get rid of the times a, little invisible times sign. So the opposite of times a is divide by a. If I divide the left by a, I have to divide the right by a. And to divide the right by a, it's really important that we use big fraction like that. What you cannot do, I'm just going to show you this here, is that would be wrong. That's for a BODMAS reason. That would only say divide the b by a, not the whole thing. So just remember that if you're dividing the whole side by something, you need to indicate that using a big fraction like that. Right, you might hate that, and if you do, don't worry, but just give this one a try for a second. See how you get on with it. Don't spend too long if you just don't like that. But yeah, give it a try, and then we'll go through it together. So pause the video and do that now. Okay, so let's first of all flip it around. RS minus D equals P. Let's go with that. Right. So first of all, I'm going to get rid of the minus D by doing the opposite, which is to add D. If I add D to the left, I've got to add D to the right, equals underneath. So that'll be RS, and P plus D is literally just P plus D. Then I've got a times S that I don't want. The opposite of times S is divide by S. So let's divide this side by S. That's P plus D all over S. Now the good thing about these is that once you can get your head around those, they don't tend to in exam make them that much more difficult. So it might be worth a look. But again, if you really didn't like that, don't worry about it. Just move on with the next thing. I'll leave that again entirely up to you. Okay, so the final topic today is sequences, particularly finding what we call the nth term. Now, if you've forgotten what we mean by nth term, do not worry, I will explain that, but I'll find it first, and then we'll explain why you'd want to do that, or why you want to find that in question B. So first of all, we've got a sequence of numbers here. This is the first number in the sequence, that's the second number, that's the third number, that's the fourth number. And what you'll notice is that these numbers are always going up by the same amount each time. They're going up by 2 in each case. So 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9. What we're going to do is we're going to take that 2 and stick it in front of the letter n. And then what we're going to do is we're going to find what we call the 0th number in the sequence. So if you're going from left to right, you're adding 2. 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9. If we go from right to left, we're taking 2. 9 take 2 is 7, 7 take 2 is 5, 5 take 2 is 3, so 3 take 2 would be 1. That's a positive 1, it's not minus 1, that's positive 1. So the nth term would be 2n plus 1. Right, that's got us a couple of marks. Why you'd want to do that, well, apart from getting a couple of marks in the exam, it's always nice. The reason we want to find the nth term, the reason why it exists as a topic, if you like, is what that allows us to do is to find any number in the sequence. If I were asked to find, the 100th number in that sequence, I don't want to have to work out the 5th, the 6th, the 7th, the 8th, the 9th, because it would take me ages. It'd be ridiculous to do that. So what we've got here to find the 100th number in the sequence is a rule that allows us to go from the position to its value. So in this case, to find the 100th number, all I'm going to do is 2 times 100, 2 times n, 2 times 100, plus 1. Well, 2 times 100 is 200, plus 1 is 201. That tells us that the 100th number is 201. Right, want to have a go at yourself, so I'd like you to pause the video and try that now. Okay, so again, I've got 4 numbers here. This is the first number, that's the second number, that's the third number, that's the fourth number. You should stress you don't have to write these out. I just think it makes it clearer what you're doing, or it's clearer to you, I think, what's going on if we do that. Right, so what's happening as you go from left to right, we are adding 4 each time. Plus 4, plus 4, plus 4. So that 4 is going to go, in front of the letter n. So if we were going from right to left, we'd be taking 4. 13 take 4 is 9, 9 take 4 is 5, 5 take 4 is 1. So 1 take 4, the 0th term would be 1 take 4 is minus 3. So the nth term is 4n minus 3. And to find the 50th number in the sequence, which again would involve a fair amount of adding, if we were to just keep adding 4, instead we're going to just do 4 times 50, take 3, well 450s are 200, so take 3 will be 197. Okay, and the final pair of questions today just flips this round. So this time we're given the nth term and we're asked to find the first 4 numbers of the sequence, first 4 terms of the sequence. So let's write them out. 1, 2, 3, 4. So all I'm going to do is literally replace n here with 1, then 2, then 3, then 4. So to find the first number, that will be 4 times 1, take 1. That's going to be 3. Then replace n with 2, so that's 4 times 2, take 1. That's going to be 7. Then 4 times 3, take 1. That's going to be 11. And then 4 times 4, take 1 is going to be 15. That's it, done. Right, want to try yourself. So again, pause the video and try that now. Okay, so I've got 1, 2, 3, 4. So I'm going to do, first of all, 3 times 1 plus 11 is going to be, that'll be 14. Then 3 times 2 plus 11 is going to be 17. 3 times 3 plus 11 is going to be 20. And finally 3 times 4 plus 11, plus 11 is going to be 23. Okay, folks, just before we finish, I want to mention one more thing. There are some topics I haven't looked at today. I wanted to list those, as you can see on the screen, and also talk about why I haven't covered those. Right, so first of all, linear quadratic graphs is something that I absolutely want everyone to be able to handle. The reason I haven't done it today is because there are currently 3 different models of calculator that people are using in class, and I didn't want to clutter the lesson by demonstrating each one in turn. So if you go to this lesson here, lesson 209, and you look under the helpful stuff column, you will see there is a video for each of the different models of calculator that are currently in use. Find whichever model you're using, that you're planning to be using in the exam, and make sure you know how to do that. In an exam would be typically 4 marks for the taking for basically just knowing a series of button presses on the calculator. So please, please, please make sure that you can do that. Y equals X equals graphs I haven't covered here, mainly because we'll see that in other places. It pops up in a couple of other topics, so it's not something I wanted to worry about for this lesson here. We'll get revision of that elsewhere. Gradient y-intercept is not a particularly horrible topic, but it doesn't tend to come up that often, so it's not something I wanted to spend any time really worrying about. If you like algebra and you feel generally okay with the graph stuff, it might be worth a little look, but again, don't spend too long on it if you haven't already looked at that. Graphical inequalities, it just links to lesson 209, so I haven't done that today because of the calculator issue, but it's something I definitely want everyone to be comfortable with. Number machines is something we'll do some more revision on as we get nearer the exam, so it's not something I felt I needed to worry about today. It's only half an algebra topic anyway, so I didn't think it was worth worrying about. And simultaneous equations, quadratics, don't touch with a barge pole unless you are really confident with algebra, unless you really enjoy algebra. Yes, they could come up, and yes, if they do, they'll be worth a few marks, but frankly, 90+% of people doing that exam will simply not be able to do those. What that topic is doing on Foundation Tier GCSE, I don't know. It seems to be very silly to be including those. So unless you really like algebra, I wouldn't worry. You can spend a long time practicing those, get good with them, and then you just have a bad day or a question comes up with a little awkwardness to it and you don't get the marks and the reward for the work anyway. There are plenty of other things I would recommend spend your time on first. Do that only for I'm going to say for fun, sounds terrible, doesn't it? But just if you really like it and you want to get stuck into a challenge, great, but don't spend too long worrying about it because it will not be the difference between anyone getting a grade 4 or even a grade 5. It's just not a topic that's that important. Right, we will leave it there. Just to stress again, if you need any help, then just give me a shout either before a lesson, middle of a lesson, at the end of a lesson. I will happily sit down. If something occurs to you and you between lessons and you want help, drop me an email. I'm more than happy to find some time to sit down with you and help you out with those. Yeah, but we will leave it there. So I will speak to you soon. Okay, bye for now, folks. Bye.